Okay, we're going to take a look at the excellence question around the go-kart, and a lot of people had trouble with interpreting the answer even if they were able to get the answer. So we'll take a look at how we do that. So first of all, a different go-kart from a starting point moves at a velocity of 6 meters per second in a straight line, and it gives us the acceleration of the go-kart at time t after leaving the starting point. Describe the motion of the go-kart as fully as possible after 4 seconds. So they've given us some information. The velocity is 6 meters per second in a straight line at the starting point. So that's when t is 0. The velocity is 6 meters per second. So that's a point, 0 and 6. And that's the starting point. That's the initial point. Now that's important because that comes into play when we integrate and so on and work on our C. So if you're trying to find motion of a go-kart and what it's doing, you need velocity. And in order to get velocity from acceleration, we have to anti-differentiate. So we're going to find velocity by anti-differentiating that acceleration expression that is given. And when we do that, when we anti-differentiate this, we get negative 2.5 T3 over 3 plus C. So we have to deal with that C. Now the thing is, this is where this comes into play, because we know that at the initial starting point, at time 0, the velocity is 6 meters per second. So that tells me that when velocity is 0, when velocity is 6, negative 2.5, t is 0. Doesn't matter what this becomes, you can see that this is going to be timesing, so it's all 0. So c is 6. So we've got our equation for velocity by anti-differentiation. And that wasn't too hard. And then the next thing we need to do, if we take a look at the question, it says describe the motion of the go-kart as fully as possible after 4 seconds. So after 4 seconds and at 4 seconds, the first thing that we need to do is when time is 4 seconds, we have to figure out what our velocity is doing at that point and how the go-kart is moving at that point. So we can get an R or a merit for this if we can get this done. So when time is 4, our velocity is going to be negative 2.5 times 4 cubed over 3 plus 6. So you got to work that out on your calculator and you get negative 47.33. Now, that's negative for velocity. You have to understand what a negative velocity means. What does a negative velocity mean? Because velocity can have a magnitude, it's not always going to be positive. But most of the situations are positive, but they're not always positive. Okay? So, if we go back up here, where did I put it? If we go back up here, there are notes. We have notes. This is taken directly out of your notes. Velocity has a direction as well as a magnitude. Negative means you're moving towards something, or down or left. So back towards something. So back towards the starting point. So this means at negative 47 that the go-kart at 4 seconds is moving back towards the starting point. So we haven't done a lot of these kinds of problems where you get a negative velocity, but it can happen. And you've got to go through your notes and make sure you understand about a negative velocity. Now we're not done with the question yet because we also want to know the distance that this thing has traveled. So a lot of people, when it says describe the motion, we also want to know how far it's gone. in 4 seconds, in those 4 seconds and so on. So we know the velocity, we know how fast it's moving and in what direction it's moving from the speed, but we also should work out the distance so that we can get a full story of what's going on with this problem. So again, we've got to anti-differentiate. Remember, if we move from acceleration to velocity to distance, we're integrating. So we're going to double differentiate, or double integrate, if you will, or whatever, from the initial expression, which is we're going to basically define that we're going to differentiate negative 2.5, the velocity function, and we're going to get negative 2.5 t to the 4 over 12, because the 4 comes down and times by the 3 to get 12, and then this becomes 6t, and then we've got another c. But we know that initially basically at time 0, the distance is 0. It's not gone any distance, so c is 0. So again, initially, in context, when time is 0, time equals 0, it hasn't gone anywhere. S is 0, and this is S. And so therefore, if you plug that all in, you're going to get c is equal to 0. So we don't need to deal or worry about the c. So now we've got our distance formula. Now we just want to know what this thing is doing at 4 seconds. So at 4 seconds, we just simply negative 2.5, 4 to the power of 4 over 12, plus 6 times 4, and we're going to get an answer of negative 229.33. Now what does that mean? The distance is negative. So again, if the distance is negative, it's going left, because negative distance, if you're positive distance, you're basically going up or to the right or away. If you're going in a negative direction, you can go in a negative direction. It just means that your displacement is getting closer to the starting point. So you're going left of the starting point in the opposite direction. Okay, so you're going to the left. So you've got to know how to interpret, again, a negative distance. You can go negative, right? It's just that you're going to be going, if your starting point is at A, instead of going in this direction and going a distance, right, you're going in a negative direction, away from. So it's very important that you are aware of what magnitudes, what the signs mean. You can get negative velocity, you can get a negative distance, and you have to be able to interpret that graphically and in context to the question.